We are not live. Okay. So, hey, I just thought I'd give you guys a quick update here. Because we got test 5 coming up this week on Thursday, right? Next week is test 6. Then we're going to have a week off for Thanksgiving. The final week, I think, is mostly going to be review. Yeah, we'll probably spend about 2.5 days on review. So I'm not going to give you any new reviews. I'm just going to be, well, I will ask you this. I have, the math department writes the final here, so I don't have anything to do with that. But I do have some old Salt Lake Community College math tentative finals. Would you guys like to practice those?
Yeah.
Yes.
We've got our hands on a similar final to the one we're going to receive.
You have one?
I don't.
I don't know. I don't think they do them. Salt Lake Community College has a packet. You could actually buy them for like $6. You could get like.
Is it acceptable if I go look through my old paperwork from my other 4th class and see if I have a final? Can we study that?
We could do that.
Yeah, I'll look for that.
I mean, I'll keep it up. But anyway, just remember that the week of Thanksgiving, enjoy your turkey, but don't forget everything. Okay? That's all I said. All right, so we're going to continue on with 6.2, which is matrix.
The test speaks on 6.1, 6.2, and what?
Okay, I'm tentatively scheduled 5.5 through 7.1.
This week is just 6.1. And then, I don't know.
Yeah, so the plan is today 6.2 and 6.3. The plan is tomorrow 6.4 and 7.1. Okay? So this is going to be big. Yeah, we're going to do a lot of graphing. Oh, I just lost my bit. Where did it go? Oh, shoot.
So,
Oh, there it is.
I decided to maybe increase my.
All right, so once again, if we can focus and cut down on the chatter, it will help you guys all do well on the test, okay? Way too much chatter. I'm glad you guys like each other, but we need to focus, okay? So please make sure cell phones are put away and laptops and everything else, and that you guys are with me so that we can do well on this. This is hard stuff. I get it, okay? Now, I'm going to let A equal 2, -3, 0, 5, 7, -1/2. And I'm going to let B equal 1, 0, -3, 1, 2, and 2. And I want you to say find A plus B. Now this is just like you would think it would be. So, Berkeley will pick on you right off the top.
Okay.
What do you think you would do if you were trying to add matrix A to matrix B?
Would you add all the corresponding rows?
Yeah, you would. Yeah. So 2 plus 1 is
3.
3. -3 plus 0.
Oh.
-3. 0 plus -3.
-2.
5 plus 1.
6.
7 plus 2.
9.
-1/2 plus 2.
-1.
Or 2 minus 1/2.
1/2.
1.5. Not bad, right? You'd be like, give me a bunch of these, right? What if I said find, how about find 5 times A?
Just times everything by 5.
Oh, there we go. Take it away, Andrew.
Genius.
So 5A would be
10.
This is also what we refer to as scalar multiplication. We're going to learn that later, but I'm going to give it to you right off the bat. Okay? So if I multiply this would become 5 times 2 is
10.
5 times -3.
-15.
5 times 0,
0.
5 times 5, 25,
35.
35,
2.5. Negative 2.5.
negative 5 halves or 2.5, that's fine. Okay, this isn't bad, right?
Not that.
Okay, how about, what if I said, find um, 2a minus 3b. You want to do it, Cameron?
So once you multiply A times 2 and then B times 3 and then subtract the 2.
Correct. So let's find 2a first. So 2a would be
4,
4,
negative 6,
negative 6,
0,
0,
10,
10,
14,
14,
and then 2. Wait, 1.
negative 1.
Negative 1.
Okay, so that's 2a. And we're going to, you can either think of this as adding a negative 3b, or I'm going to write it this way, minus 3 times this. Okay, how's that? So 3 times this is,
1.
nope, 3.
3, yeah, sorry.
Okay,
0,
0, I'll do it this way.
negative 9,
Negative 9,
3,
3,
6,
6,
6.
6. Okay, so now we need to subtract these. So this becomes
1,
4 minus 3 is 1,
negative 6,
negative 6,
negative 9,
positive
yeah,
9,
positive
negative,
9.
negative, right?
Yeah. 7,
7,
8,
8,
and then that would be negative, or 5.
negative 1, minus 6 is negative 7.
Yeah, negative 7.
Okay? All right. These aren't too bad, right? Okay. All right. What if I said, I'm trying to see, these are common sense, but I'll give it to you just because it looks funny. Okay? So let's talk about properties. You've done all these mostly correctly. Addition and scalar multiplication. Okay? So let A, B, and C be M by N matrices. Let, and I'm going to use a lowercase c and a lowercase d be scalars. Just like we did here. We were going to refer that 2 and that 3 as a scalar. Okay? So, let me ask you if you think matrix A plus B equals B plus A. Does the order really matter? Yeah, it doesn't matter. So this is what we refer to as the commutative property. Commutative. Okay? The associative property says A plus B plus C equals A plus B plus C. So that's also true. Okay? We can also do the associative scalar multiplication. Okay? Which says this is going to be a lowercase c plus d. Sorry, I did that wrong. C times dA equals CD times A. Okay, so you can move the scalars around. We also have the distributive property. Which says C times, this is a lowercase c. We shouldn't use the c. Let's annoying. C times A plus B equals CA plus CB. Okay? So that's really nice because basically matrices follow all the same rules you always learned. Okay? I'll give you a hint. We can do scalar multiplication. We can also do matrix multiplication. It's nice that this is true for scalars. It is not true, not necessarily true. It could be true. It is not necessarily true for matrix multiplication. Okay? All right. So, let's do, what if I said I'm going to let A equal the matrix 2, 3, negative 5, 1. And I'm going to let B equal 4, negative 1, 1, 3. And X is the unknown matrix. Okay. So I want you to say solve 2x minus A equals B. Okay? Now, this first part should be fairly easy. Victor, could you solve this for x?
Yeah, move the A together.
So how do I move the A?
Plus A.
I need to add A. Now, the nice thing about this is this becomes
2x equals B minus A.
B plus A.
Yeah.
Or I could write A plus B because it's commutative, which is a really, really nice feature. You're going to find out when we do matrix multiplication, it's not commutative. And then order will really matter a lot, okay? But for addition, it doesn't matter, okay? So then, how do I solve for x?
Divide by 2.
Divide by 2. Okay, and so I'm going to divide that by 2, and I'm going to divide that by 2. So a couple ways I could write this: x equals 1/2 times A plus B, or B plus A. Doesn't matter, right? Okay? All right, so if x is the unknown matrix, this is A, this is B, I can now solve for x. Okay? So x equals 1/2 times A and 1/2 times B. Yes?
Can you just add them together and then times by 1/2?
Could I? That's a good question.
Yeah.
Yes, because of which rule?
Probably distributive. Associative.
The associative yeah, both of these associative rules work. So yeah, we could add them. So we could either add them together first and then multiply, or we could multiply them first and then add them. What would you like to do?
Isn't that the distributive property? Because like.
Yeah.
Okay.
Yeah, it is distributive property.
Okay.
They all go together. Okay?
And I'd rather add them together and then.
Okay, so we're going to add them together and then multiply by 1/2. Okay? So if we add them together, you're going to get
6.
6,
2.
2,
Negative 4.
negative 4,
4.
4.
And then you just.
So x is going to equal
3, 1, negative 2, 2.
Okay? So there you are. There's your first matrix algebra you've ever done. Unless you have this class before. Okay? Good stuff, huh?
Yeah.
All right. So let's, oh, here we are. Now we're ready. I've been warning you, and now we're there. Okay? Now we're going to talk about matrix multiplication.
The same chapter.
Same chapter. Which should not be confused with scalar multiplication, which is what we just did. We just did scalar multiplication. We're now going to do matrix multiplication. Okay? Now, if A is an M by N matrix and B is an N by K matrix, then their product is an M by K matrix. Very important definition. Okay? So, here's what we do in this case. So, and I'm going to circle the M by the K, okay? And I'm going to do this. The N's have to be the same. In order to multiply two matrices, the N's have to be the same. So here's what we mean. So let me give you an example. I'm going to let A equal 1, 3, negative 1, 0. I'm going to let B equal negative 1, 5, 2, 0, 4, 7. Now the first question I have is, do you think you could add those together?
No.
No, because they're different dimensions. Okay? What is the dimensions of this one?
2 by
This is a 2 by 2, right? This is a what?
3 by 3.
2 by 3. Okay?
Do you do long ways and then like?
Yeah, we'll get there. Okay? So whenever we're multiplying these two middle numbers have to be the same. Okay? And if they are the same, then your final matrix is going to be the outside numbers. Okay? So if I multiply these together, I'm going to get a 2 by 3 matrix, which is going to look like this. Okay? So I'm taking a 2 by 2, I'm multiplying it by a 2 by 3, I'm going to get a 2 by 3. Here's how matrix multiplication works. And Berkeley was kind of on the right track. I'm going to take the first row, I'm going to multiply it by the first column. Okay, here's how I'm going to do that. Okay, I'm going to take 1 times negative 1 is negative 1, and then I'm going to add 3 times 0, which is 3. Okay?
Can you do that again?
I am going to do it again, but I'm going to do it on a different one. Now, I'm going to take this row, I'm going to multiply it by this column. 1 times 5 is 5. 3 times 4 is 12. You can add them together.
Always.
Okay? Then, it's a good thing I brought lots of colors today. We're going to do this times this. Okay? 1 times 2 is 2. 3 times 7 is 21. Okay? Now, we're going to do the same thing with the second row. Okay? We're going to do the bottom row times the first column. Okay? So negative 1 times negative 1 is positive 1. 0 times 0 is 0. Then we're going to do, I've only got 5 colors, the bottom row times the middle column. So negative 1 times 5 is negative 5. 0 times 4 is 0. And then, I'm going to have to go back to here, the bottom row times the last column. So negative 1 times 2 is negative 2. 0 times 7 is 0.
Your first
First
product is
one
wrong.
should be plus 0.
Yeah, it should be plus 0, you're correct. 3 times 0 is 0. Okay? Now, let's simplify. This becomes negative 1, 17, 23, 1, negative 5, negative 2. That is matrix multiplication.
It's disgusting.
Disgusting. Okay, so this is what we would refer to as A times B. Now the question is, is B times A equal to A times B?
No.
No. Okay? Not only no, but it's not even possible. Okay? Because the order matters in this case. So we just did AB. Now we're going to do BA. We got 3 by 2 times a 2 by 2, right? We're doing this, yes. So in this case, these do match, but it is a 3 by 2. So I've got 3 rows, 2 columns.
Oh, you're just off camera.
Oh, off camera, thank you. Okay, so in this case,
Why did it switch to 3 by 2 instead of being a 2 by 3? Because B was a 2 by 3 before.
B is a 2 by 3. You're right, because I wrote it wrong. I was like, this isn't even supposed to work. 3 by 2, no, it's a 2 by 3. 2 by 3 times 2 by 2. Can you multiply those together? No. So, sorry, it doesn't even work. It's impossible. Not only is it not the same, but it's impossible. Incompatible. So, BA is not possible. Okay? So, in this case, it is not commutative. Okay? Yes.
So does that also work for division?
There's no such thing as division.
Why not?
Because we can do multiplication, we can't do division.
Okay, so if it's addition or subtraction, you can do commutative, but if it's timesing them, you can't.
Yeah, we don't have any way to actually define division.
When we're finding the dimensions.
We can do something called the inverse matrix, which I can't remember if we're going to cover that today or tomorrow. But we will do an inverse matrix, which will be kind of like division, but not.
We should go over it just for fun.
For the
And it will
dimensions,
be fun.
would you do like up and down or side to side for all of them? So like 2 and then 3 across?
2 and I'm not
So
sure.
like on the 2 by 3, like if you're finding the dimensions, you would do up and down. So there's 2 up and down, and then there's 3 side to side. So the 2 would come first over 3.
So
Finding dimensions.
I'm going to refer to this as row by column
Okay. Okay.
and
yes.
row by column. You're calling them up and down, and I'm getting
Yeah, I'm like,
confused.
I don't really know. Yes. So you can do row by column.
Yeah, so in this case, this column has to equal those number of rows, or it's not possible. And that's why when we did it the other way, these are not the same, so therefore it's not even possible. Okay? So while scalar multiplication is commutative, matrix multiplication is not commutative. Not always commutative. Sometimes it's possible. In this case, it's not even possible.
What if you did a 4 by 4 times a 4 by 2 or 4 by 3? Yeah. Is that like?
Yeah, you could do that.
Okay. You just do the same.
Let's see what other examples we've got here. All right, let's see here. Oh, I thought we would do some more in here. You want me to make one up? Okay, so you wanted to do what again?
4 by 4
4 by 4
by 4 by 3.
by 4 by 3. Okay, is that possible?
Yeah.
Okay, what will be the final? Let's do something different. Let's do a 4 by 3 times a 3 by 2. Okay, is that possible?
Yeah.
Yes, because these match. What is the final resulting matrix going to be?
4 by 2.
It's going to be a 4 by 2. So if I've got a 4 by 3, 1, 2, 3. Let's see, I've got 4 rows. 1, 2, 3, 4. And then, yeah, 4 by 3. So 2, 0, 1, 3, 3, 3, 1, 1, whatever. And we're going to multiply that by a 3 by 2. 1, 2, 3, 4, 5, 6. Okay. So if this is A equals, this is B equals, we're going to find AB. Okay. So the first thing we have to do is we said it was possible. This is going to be 4 rows, 1, 2, 3, 4 by 2 columns. Okay, so I'm taking a 4 by 3, a 3 by 2, and I'm getting a 4 by 2. So they're not even the same shape anymore. Okay, so do we have any volunteers who want to do this one? Do you know?
Would you just do like 1, 2, and 3 times 1 and 4?
Yeah, so we're going to take the first row, we're going to multiply by the first column. So this becomes
1, 4.
1 plus 4 plus 9, is that what you said?
Yeah.
Okay, and then what?
And then you do the next row times the same.
You do the same.
A2, like A second row.
Times this, right?
Yes.
Okay, so 1 times 4 is
4,
plus
10,
10 plus 18. Okay, then what?
then you move to the next row. A2.
Next row times the first column. This becomes
2,
2
0,
plus 0 plus 3. And we'll do it again. This times this, right?
8, 0.
8 plus 0 plus 6. Then we will do this times this.
3, 6, 9.
And what times that now?
12, 15,
18. And finally, the bottom row.
4, 2, 3,
4 plus 2 plus 3. And
16, 5, and 6.
okay, so my final answer is
14,
14,
32,
32,
5,
5,
14,
14,
18,
18. So that comes 30, 45,
9.
9, 27.
I already did.
All right, pretty good, huh?
I have a question about the matrices.
Okay.
Matrices we're working with. So if it's like a 2 by 3 column or whatever, like we just made, what would that equate to? Is that 14x equals 32? Like the final product?
Well, I'm glad you asked. I'll answer it now. Okay? So you've all learned the row echelon form, right? Hopefully, and if you haven't, you'll learn it by Thursday. Okay? Now, let's say, for example, here, okay, so what I can do here is I can do 1, negative 1, 3, 1, 2, negative 2, 3, negative 1, 5, times matrix x, y, z equals 4, 10, 14. Okay, now, let's think about this for a minute. Probably shouldn't have used red, but. Okay, so if you were to do matrix multiplication, this is a 3 by 3. This is a 3 by 1, right? And this is a 3 by 1 as well. Okay? First of all, is this even possible?
Yes.
Yes, these two match. I'm left with 3 by 1, so yes, it is possible. Okay? Now, if you were to take this matrix and multiply it by this, what would you get?
You'd get,
You get this times this, right?
yeah,
So that would be
so that's 1, or just x minus
x
y
minus y
plus
plus
3z
3z equals
4.
4. And then on the next row, you would get
Back and forth.
who wants to do the next one?
Oh.
Victor, you must.
It'd be x,
X.
2y.
Thanks, Victor.
Oh, sorry.
Plus 2y, it's okay. We'll let Cameron take it over. I don't think Victor was that excited about it.
Minus qz,
Minus 2z equals 10, and
3x
3x
minus
minus
y
y
plus
plus 5z equals 14. So we can take, so you can see this is another way to write your original three equations in 3 unknowns. Okay? So we could refer to this as matrix A, matrix X, and matrix B. Let's say AX equals B.
Oh, that's crazy.
Yes.
So is that basically what we were doing yesterday, kind of like?
Well, this is a different method for doing what we did yesterday. But yes,
Yeah, with the
if you start with this, you could move to this, and you can now do matrix algebra. Now the problem is with this. Oh, is that where they stopped? Okay, so we have a big problem here. And the problem is, if you have AX equals B and these represent matrices, we cannot divide, right? I haven't taught you, and in fact, there is no way to divide matrices, correct? There is, you can take my word. It would be nice to divide both sides by A, but we can't. Can't do that. It's not allowed in matrix algebra. Okay, so how could we get rid of that A?
by X.
Divide by X, we don't want to do that either. Okay, so that leads to what we refer to as the inverse matrix. Okay, so this now leads us into 6.3, where we're going to talk about inverse matrices. Okay, now, before we talk about the inverse matrix, let's talk about what we refer to as the identity matrix. Identity matrix. Okay? And sometimes we refer to it as I2. Okay? I2 is 2 dimensionals, 1, 0, 0, 1. Okay? This is what we refer to as the identity matrix. If we have it in 3 dimensions, it's going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, I4, you could probably figure out 1, 1, 1, 1. Okay, so you've got the 2 by 2, 3 by 3, 4 by 4. So the identity matrix is always going to be a square matrix. Okay, now what's cool about the identity matrix is, okay, let's multiply a couple of matrices together with the identity matrix, okay? Well, I'll follow, but we could have probably done it with that, but that's all right. Okay, so let's say that I want to multiply 1001 times 356 negative 127. Okay? First of all, the first question is this even possible? Spencer?
Yeah,
Yes. Because this is what kind of a matrix?
that is a 2 by 2.
2 by 2.
3.
And this is a 2 by 3. Those match, so my final matrix is going to be 2 by 3. Okay? Now let's go ahead and multiply these together. Okay? So, Hunter, do you want to do that? Sure. Okay, so I'm going to multiply this times that. We're going to get
3. Yes, 3 plus 0.
Okay, and then we're going to multiply it by this.
5 plus 0.
5 plus 0.
And 6 plus 0.
6 plus 0. We'll do the bottom.
And then 0 plus or minus 1. And then 0 plus 2.
Now it's getting confusing, right? 0 plus 2
0 plus 7.
and 0 plus 7. So this equals 3, 5, 6, negative 1, 2, 7. What do you notice about this and this? It's the exact same thing. Okay? So one way to think about the identity matrix is this is the same thing as multiplied by 1. But the fact of the matter is, if I multiply by 1, 1, 1, 1, would I get the same thing as this? No. Not. It's something different. Okay? So you can think, so that's what's special about the identity matrix, is it's kind of the equivalent of multiplying by 1. Okay? Because if you take the identity matrix, multiply it by any matrix, you get that same matrix back. Okay? So that's what's special about the identity matrix. Now, okay, so here, as we get into this, let's talk about the inverse of a matrix. Okay, I'll go back over here. Okay, so the inverse of a matrix, that's kind of where we were going with this. Okay, so the definition is A times A inverse equals A inverse times A. So this is commutative. This is probably the only case where matrix multiplication is commutative, and it equals the identity matrix. So it doesn't matter whatever dimensions you are. That's why I have I2, I3, I4, okay? So, I don't like where they're teaching this. Okay, I'm going to teach you something for, this is actually 6.4, but I think it's going to be really helpful for 6.3. The determinant of a 2 by 2 matrix. Okay, this is actually 6.4, but I think it'll really help you. If I have a matrix A, B, C, D, the determinant of A, if we refer to this as matrix A, is going to be A, I hate using lowercase letters, A, D minus B, C. Okay? So if I had a matrix 1, 2, 3, 4, okay? Could you find the determinant, Kelly?
Yes.
Okay? The determinant would equal
It'd be 1 times 4, so.
1 times 4 minus
2 times 3.
2 times 3. So 1 times 4 is
4,
4 minus
6,
6 equals
-2.
-2. Okay?
Is that always the formula?
That's the formula.
A times D minus B times C.
A times D minus BC.
And this is only the two.
This is
two by
for
two.
a 2 by 2 determinant.
Will we get the 3 by 2?
We will get it to 3 by 3, but not today, okay? Now, there's a reason I want to show you this now, because it's going to help later, okay? Just to make sure we're clear on this, -1, 3, 4, 1. Let's make sure that Jonathan can find that determinant really quickly and easily.
Of the -1.
Yeah.
So it'd be -1 times 1, minus 3 times 4.
Okay, so this becomes,
-1 minus
which equals
-13.
-13. Okay, so you guys feel pretty good about that?
Oh, yeah. Sure.
I'm trying to decide if I should show this to you because it feels like cheating, and you can't do it on the 3 by 3, and we are going to get to 3 by 3s. Okay, we were talking about inverse matrices, okay? They have this nice little formula here. You'll see why it's cheating in a minute.
We're approaching. Not tests.
The problem is, you need to learn this the hard way for the 3 by 3, and this is really nice if you have 2 by 2, okay? So, we back up to section 3 by 3. So the inverse of a 2 by 2 matrix. Okay? And I'm going to change this a little bit. So if A equals A, B, C, D, then A inverse equals 1 over the determinant of A, which I just taught you how to find that, times, you flip these two, B and A, and negative C and negative B. Okay? So that is a very cheating way. I don't really even think I wanted to show you that yet.
Well, we saw.
So let's talk about this matrix right here. If I have the matrix 1, 2, 3, 4, okay, which I've just done right here, okay. So if this is A equals, I can use this dumb formula, which I don't really like, but you guys are gonna like it, I know, because you like to memorize stuff, okay. So this becomes 1 over, what's the determinant of that? Negative 2. We found that right here, right? 1 over negative 2 times, now we're going to flip-flop these two, okay? 4 and 1. And now we're going to keep these in the same place, but we're going to make them negative, okay? So this becomes negative 3 and negative 2. So now A inverse equals negative 1/2 times this. So this becomes what? Now it's just scalar multiplication. Niels? Negative 1/2 times 4 is?
-2.
Negative 2. Negative 1/2 times negative 2? 1. Negative 1/2 times negative 3? 3 halves. And negative 1/2 times 1? Negative 1/2. Yeah, I'm sure you all like that. That's cheating. Okay? Now, let's prove. I'm going to erase that because we've already got it here. Let's prove A times A inverse equals the identity matrix in 2 dimensions. Question.
So how did you get 4, -2, -3, 4?
I used this dumb formula here. I did 1 over the determinant, which was, we found previously the determinant was -2, okay? But they put AD minus BC with the determinant. That's what it is.
Okay.
And then I multiply, and then I flop these two,
Oh.
and I made both of those negative. I kept them the same, but I made them negative. So this is a really dumb formula, okay? But it illustrates a point, okay? This is how we're going to be able because Berkeley earlier said we can't divide, but we can multiply by inverses, okay? So the idea here is I want you to prove that A times A inverse equals the identity matrix, okay? So if A is 1, 2, 3, 4, and A inverse is -2, 1, 3 halves, -1 half, I'm telling you, without doing any math yet, but we are going to do the math in a minute, that this equals 1, 1, 0, 0. Do you believe me?
I trust you.
You trust me. Okay, so Christian, let's prove that multiplying these two together equals that. Okay, so this is a what kind of a matrix?
2 by 2.
2 by 2. This is a
2 by 2.
2 by 2, so the final matrix is going to be 2 by 2. Okay, so you take this times this. -2. 2's cancel.
Oh, there's 3.
Plus 3. Then we're going to do this.
And then
1.
2.
2's cancel.
What's your handle?
Minus 1.
-1. Oh, sorry.
Yeah. These 2's cancel, right? So it's left with -1. Okay, now we're going to do this one.
3 times, so that'd be -6.
-6.
And then plus 4.
4 times, so the 2 cancels the 4, right? How much with the 2 times 3 is,
Wait, what are you doing?
I'm doing this times this.
Okay, yeah.
So -6, the 4 and the 2's cancel, 2 times 3 is 6, okay? And now we're gonna do the last column here. 3 times 1 is
3
3,
plus
2 goes into 4 twice, and I get -2, right? -2 plus 3 is 1, 1 minus 1 is 0, -6 plus 6 is 0, 3 minus 2 is 1.
That makes sense. I knew it.
Okay? All right. Does that make sense?
Nope.
Nope.
Is there a way to do it without the formula?
Yeah, there is, and I'm going to show you that. We're going to start with a 2 by 2, and hopefully we'll finish with a 3 by 3. Okay? Now, in fact, we've only got 15 minutes left. I feel like we need to hurry a little bit. Okay, so here's how you would do this without the formula. And oh, by the way, this is what you're going to have to do with a 3 by 3. Okay, so I'm going to take the same 1, 2, 3, 4, 1, 2, 3, 4, and now I'm going to say find a inverse, and I'm going to do it without this dumb formula this time. Okay, so here's how you do this. Okay, so 1, 2, 3, 4. I'm going to draw some dots here. I'm going to put the inverse matrix next to it. Okay. Now, this is gonna
That's the identity matrix.
What'd you say? Sorry, that's the identity. I said it wrong. The identity. I'm going to put the identity matrix right next to it. Okay. So here's the goal. I want to turn this side to the identity matrix, and then this side will be a inverse. That's not too bad with a 2 by 2, but it does get bad with a 3 by 3. Okay? So the goal is I want to get a 1 here. Guess what? There's already a 1 there. Okay? So I'm going to work down, and then I'm going to work up. I need to get a 0 here. How do I get a 0 here? So I'm going to do -3 times here. So my top row is going to stay the same. 1, 2, 1, 0. -3 plus 3 is 0. -6 plus 4,
2.
-2. -3 plus 0, -3. 0 plus 1 is 1. Are you with me so far?
One second.
Maybe I shouldn't rush. Well, you with me so far?
Yeah.
Okay, now I need to turn this into a 1. What's the easiest way to do that?
Times by,
Turns it off. Never mind, I'm getting out of myself.
What are we doing? Turn the-
I need to turn this -2 into a 1 somehow.
How do you divide by negative divide by
2.
Divide by
Negative.
-2, right?
Yeah.
Okay, so if I divide by -2, I'm going to get 0, 1. This becomes 3/2, -2, and this becomes -1/2. Correct?
yeah,
So I've got the second row is set now. Now I need to turn this 2 into a 0 somehow. So I'm going to multiply this by -2, and then I'm going to add it, right? Okay, so this becomes 0 plus 1 is 1. -2, sorry, I want to do this by +2. +2, no, I want -2. -2 plus 2 is 0. These 2's cancel, right? And I'm left with -3 plus 1 is -2, right? And the negatives cancel, so I'm left with +1 plus 0 is 1. Okay?
that's
Now
it.
look at this. That's exactly the same as that. Okay? So you can remember this dumb formula if you want. And it is relatively easy, or you can learn this method, but here's the problem.
That only works with 2 by 2.
This only works with 2x2s, it does not work with 3x3s. And with a 3x3, you have to do it this way.
Dang it.
Okay? And so that's why I would rather you did this, because 3x3, there's no nice easy formula for you. Okay? So let's do a 3x3. Hopefully we can do it in 10 minutes. Okay, A equals 1, -2, -4, 2, -3, -6, -3, 6, 15. Okay? So Bailey, what should my first step be when I'm trying to find an inverse matrix?
Set it to the identity or
I'm going to add the identity matrix here. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? What's my first goal? I want to get a 1 right here. Luckily, it's already there. Okay? What's my second goal? Zeros and zeros, right? So, what's the easiest way to get a 0 and a 0 on the second row? So -2 times the first row plus the second row will give me a 0 here, right? Top row is not going to change. Okay, so I'm just going to rewrite the top row. 1, -2, -4, 1, 0, 0. Okay? All right, so -2 plus 2 is 0. +4 minus 3 is 1. That was lucky. Hopefully they're all this easy, right? Because we want a 1 there in the next step anyway. +8 minus 6. +2. Okay. -2 plus 0. -2. 0 plus 1. 0 plus 0. 0. Okay. Now, the next step must be Caitlin's turn. How do I turn this -3 into a 0?
Just turn the -3 into a 0, we do the top row times +2, right?
Right? 3 minus 3 is 0. 3 times -2,
-6,
-6 plus 6.
0.
Oh man, you guys are lucking out. This is too easy. Okay? Negative 12 plus 15,
Is 3.
3. 3 plus 0,
Is 3.
0 plus 0,
0.
0 plus 1.
1.
Okay, what's my next goal?
Make that 3 into 1.
The negative 2 to 0.
No, so at this point, so you still need to work in columns. My next goal is to turn this into a 1. Lucky it's already a 1. My next goal is what? I need to get a 0 here. Luckily it's already a 0, but I need to get a 0 here. Okay, so bottom row is okay, so I'm going to rewrite the bottom row. 0, actually, now let's change the bottom row, because if I divide by 3, I can get a 1 here, right? 0, 1, 1, 0, 1/3.
Isn't it? Okay.
Okay, the bottom row is now cool, right? Now, middle row is okay as well. 1, 0, 1, 2, negative 2, 1, 0. So now I've just got to turn that into a 0. Berkeley?
Should you times the top row by 1?
By 1?
The bottom one by 2.
Or well,
Middle row by 2 would be better, right? Okay. So let's multiply the middle row by 2 and then add. So 0 and 1 is, Berkeley, 2 minus 2.
or that's 1 minus 2. So it's
No, it's 2 minus 2. 2 times 1 is 2. 2 minus 2,
0.
0. 4 minus 4.
0.
Oh, you guys, this is an easy one. You guys are lucking out. Okay. Negative 4 plus 1
Is 3.
negative 3.
And then
2 plus 0,
2.
2. 0 plus 0.
0.
Okay. So we're really close now, right? So this is the last thing I need to do because that's already a 0. Normally you don't get that lucky. It's a good thing because we were short on time. Okay, so how do I turn this 2 into a 0? I picked on Angel. I don't think I picked on you.
Yeah.
How do I turn that 0 into, or that 2 into a 0?
By the bottom by negative 2.
Bottom by negative 2. So the bottom row is going to be the same. 0, 0, 1, 1, 0, 1/3. Oh, I'm still on the board too. Okay. Now, middle row.
0, 1.
Okay, so 0 and 0 is 0.
So I just like,
0 and 1 is 1.
I keep my matrices in the middle, but I do that like mental work on the side because I tripped up. Is that okay?
Whatever works for
So
you.
I just wrote it down.
This works for me, but
So
whatever
that-
works for you.
So that will produce 0, 0, negative 2, negative 2, 0, 2/3, which if you have that is.
You're going too fast for me. Negative 2 minus 2 is negative 4, right?
Yes.
0 and 1 is 1. Negative 2/3 plus 0 is negative 2/3. Correct? Top row is already okay, so 1, 0, 0, negative 3, 2, 0. What's your inverse matrix? Right there. 2 divided by 3. Okay? That one was probably easier than you're going to get, but it was a good demonstration. Now, let me ask you a couple of questions here since we're short on time. What would happen if somewhere, as I'm doing all of these row things, I get 0, 0, 0, 1, 0, 0?
It's undefined.
No solution, right?
Yeah, so there is no inverse matrix. Not all matrices are invertible. One way to do that on a 2x2,
Do the equation.
let me see if I can make up one in my head. 1, 2, 1, 2. Huh. Okay, what's the determinant of that?
It's 2 minus.
2 minus 2, which equals 0, right? So if we're using our formula, we got a big problem because we got 1 divided by 0. Therefore, no A inverse exists. So if you're doing a 2 by 2 and you get a determinant of 0, that was what I just made up in my head, then no inverse. So not every matrix is invertible. Okay, so now here's what I want to do. I know we're short on time. Since we've found the inverse matrix already, okay. So let's say, for example, this is matrix A. Here's about 3. This is matrix A right here. Okay, and oh, I guess I didn't let people see that. Maybe they did, I don't know. Okay, so I've got inverse A, matrix A, and if I let X equal X, Y, and Z, and if I let B equal 7, 5, and 0. Okay, so this is my original A here. So I've got A, X equals B. Okay, this will give me a 3 by 3 equations, right? 3 equations, 3 unknowns. Now, as Berkeley pointed out at the beginning of class, we cannot do matrix division, okay? But we can do the inverse matrix. So if I multiply this by the inverse matrix, and order matters a lot here, okay? This becomes the identity matrix, right? And so essentially that goes away. But of course, I need to do the inverse matrix here. And so therefore, A equals the inverse matrix times B. Okay? And so that's how I can solve for matrix X. So if I take A inverse, which is this here, I'm going to rewrite that. So A inverse is -3, 2, 0, -4, 1, -2/3, 1, 0, 3. And if I multiply that by matrix B, 7, 5, 0, first of all, is this possible?
Yeah.
Yes, it is. I've got a 3 by 3 and a 3 by 1. Those match. My final matrix is going to be 3 by 1. Okay. So now I can simply multiply these together, correct? Okay. So, whose turn is it? Kelly, it must be your turn. -3 times 7, -21. 2 times 5, 10. 0 times 3,
0.
Okay, and then we've got -4 times 7. We'll pick on Spencer. -4 times 7.
That is -28.
-28. 1 times 5.
5. And then 0.
0. And Victor, 1 times 7.
7.
0 times 5.
0.
Plus 0. So X, Y, Z equals -21 plus 10.
-11.
-11. -28 plus 5.
-3.
23. And 7, right? So I just solved that using inverse matrices. On this upcoming test, I'm going to say I want you to solve it a certain way. Solve it with inverse matrices. Solve it with determinants, Cramer's rule, which we'll learn tomorrow. Solve it with the 3 equations, 3 unknowns, elimination, substitution. Okay, so you're going to have multiple ways to solve these. I am going to specify the method on the test. Okay? So, would be easier with 2 by 2. Oh, we've got a few minutes left. Okay, we've got 4 minutes left. Maybe we can do a quick and easy 2 by 2. We're going to do it with inverse matrices this time. Okay? So in this case, I'm going to say solve by inverse matrices. And we've got 2, negative 5, 2x minus 5y equals 15, 3x minus 6y equals 36. Okay? So Angel, how would I do that?
So you could do a 2 by 2 and then a 2 by 1.
Correct. So I'm going to let A equal
A equals 2, 5.
2, negative 5.
Oh yeah, 2, negative 5, 3, negative 6.
3, negative 6. X equals X and Y.
Yes.
And B equals
15.
15 and 36. Okay, so if I've got AX equals B, how do I solve that with inverse matrices?
So you would find the determinant. So
Well, you multiply this by A inverse, right?
Yeah.
A inverse. So X equals A inverse times B. Okay? Because we're short on time, I will let you use that crap formula. So I need 1 over the determinant. What's the determinant of this?
It's negative 12.
Negative 12 times minus
Minus negative 30.
negative 15. So this becomes positive 15. So this becomes 1/3 times. Now we need to flip these two, right? So negative 6 and 2, and then we change the sign on both of these. Negative 3 and positive 5. Okay? So A inverse becomes 1/3 times negative 6, Hunter. Negative 2, 1/3 times 5, 5/3. 1/3 times negative 3, negative 1. 1/3 times 2, 2/3. Okay, so now all I need to do is take that times this. Okay, so I've got 2, negative 1, 5/3, and 2/3. I'm going to multiply that by 15 over 36. 2 by 2, 2 by 1, it's going to be a 2 by 1. Okay, Andrew, 2 times 15 is?
Say again?
2 times 15, 30, 5, let's see, 3 goes into 36, 12 times, 5 times 12, 60. 15 times negative 1,
2 times negative 1.
negative 15. 2/3, so 3 goes into 12, so 2 times 12 is 24, right? So this becomes 30 plus 60, 90,
9.
and 9 equals XY. That was actually fairly quick. Okay. So do you feel comfortable doing all these?
Actually, more practice, I understand.
Yeah, this is
Super
gonna take
simple.
practice. Probably gave you way too consider homework, but practice as many as you can. Quiz tomorrow will be on 6.2 and 6.3.
Oh, and that's the other problem.
Oh, the other problem.
Oh, shoot.
I went down there. 1 second.